Okay, so again, we're talking high-level ellipses and hyperbolas. Last class, someone was like, I thought you said eclipse, not ellipse, and wrote that down in their notes. So don't do that. These are ellipses that we're talking about. So an ellipse definition here is a set of points on a plane, or in a plane, and the sum of those distances are from two fixed points is constant, okay? The equation is similar to the circle of x minus h squared plus y minus k squared. However, it's not equal to r squared, it's equal to 1, and then it's divided by an a squared and a b squared. So basically what that is the a value, if you find the a value and you find the b value, that's going to be your distance from the center horizontally for a. So it would be like this distance is a, this distance is a, and you would have 2 points here on your ellipse. And then your b value is going to be your vertical distance up and down from that center point. And that kind of looks like a circle, but if you were to connect all these points there, that was a really terrible job, but you get the idea. That's what forms your ellipse. That's how you get those points there. And technically, there's some foci points as well. We're not going to really get into that too much. We're just going to, again, talk high level of the ellipses, okay? Does that make sense, that picture there? So the stuff that's underneath the x squareds, that's your x distance from your center, and then underneath your y squared is your y values from the center, okay? So this equation that you're given here, we're got x minus 2 squared plus y minus 1 squared, and that's over 9 and 16, and it's equal to 1. So it's equal to 1, so I know that it's going to be an ellipse here, and it's a plus sign. Anytime you see a plus and that it's equal to 1, it is an ellipse, okay? So my center point would be at the opposite of x, so 2, and then opposite of y there, -1. So 2, -1 is my center of my ellipse. Now, if I take the square root of my denominators, the square root of 9 gives me 3, and then the square root of 16 gives me 4. That's the distance from the center to both sides of the endpoints on my ellipse. So from this point horizontally, I'm going to go over 3, and then vertically, I'm going to go up 4 and down 4. Okay, and if I were to connect all these points here, the best I can with not being a notability, that forms my ellipse. Some other kind of vocabulary is that whichever values are smaller, so like if my x values are smaller, this distance here, this is what we call the minor axis. And then this is what you would call the major axis because it's longer, but sometimes that could be swapped around, and then your major axis could be along the x instead. Okay, so my domain, if I was looking at what my domain is of this function, my x values farthest to the left would be -1, and farthest to the right would be at 5. And then what would my range be for this picture here? What's my lowest point at? 6, I think, right? Yeah. -6, and then +3. Oh, can I not count? It sure is -5, yes. Okay. All right. It's nice if they give it to you in the form already. To be able to draw it is not too bad. Now, example 2, it is not in standard form, or it is written in standard form. It's not in the factored form to give us what the center is and stuff, so we are going to have to complete the square, and this is where it is a little tricky. So it's going to be okay. We're going to split up our x's next to each other, and then I'm going to split up my y's over here. And then I'm just going to move that 61 over to the other side, because that 61 does not look like it's going to help us complete the square at all, right? Okay. In order to factor these things into something like x plus or minus something squared, I'm going to have to get rid of that 4 in front, right? And I'm also going to have to get rid of that 9 in front of the y squared. So what we could do is let's factor it out. So if I factored a 4 out, I would have an x squared minus 4x, right? We still need some number inside there to complete the square, but let's just factor it out to start. Then for the 9y squared plus 54y, I'm going to take a 9 out, be left with y squared plus 6y, and that's going to equal -61. Okay, now to complete the square, remember we take our b value, so this first one is -4, and I divide that by 2 and square it. So again, I take the b value, 6, divide it by 2, and then I square it. Now technically this number here, the first blue one, this is actually just a 4, right? And this number here is just a 9. But am I only adding a 4 and a 9 to the left side there?
No, you're adding it to the right side.
I'm also adding it to the right side, but am I only adding 4 and 9 to the right side? Look at this. We got a 4 here, outside. Don't I need to distribute that? I sure do. So I need to actually add a 16 to the right-hand side in order for that to be equal.
I know, right? Okay.
And then I take this 9 and multiply it by that 9 and make this an 81. Does that make sense?
Okay, we got that.
If I rewrite this, this becomes 4 times, this would be x minus 2 squared. To get the x squared minus 4x plus 4, right?
Right.
And then if I have a 9, what's my next factored form going to be? How do I factor y squared plus 6y plus 9? Y plus 3. And then on the right-hand side, if I add all those numbers together, I'll tell you, you're going to get 36. But if we want to write this in standard form, we need to get rid of that 36, right? Because it's supposed to be equal to what? 1. So let's divide all these things by 36. So divide by 36, divide by 36, divide by 36. And now I can just simplify these fractions here. So this is going to become x minus 2 squared divided by, what's 4 over 36? Going to simplify 2 down there. A 9. And then I've got y plus 3 squared divided by a 4, and that equals 1. So this is now my form of an ellipse in that standard form with my center there at 2, -3, and then my horizontal axis would have that radius of 3 down there, and my vertical axis would have that radius of 2 to make that ellipse shape. Okay. All right, hyperbolas. Hyperbolas. It was a little too big there for that type. Let's zoom in. Well, that's fine. You get the idea. Hyperbolas is the set of all the points in a plane such that the absolute value of the difference of the distance from two fixed points is constant. It's a lot of words for what that means. Is basically we've got two parabolas, hyperbolas. I don't know, like there's multiple of them. I don't know. There are two diagonal axes or diagonal asymptotes where the parabolas are basically in between. Okay, so like we've got two examples here, or two formulas, where it's centered at the origin. Okay, if it was not centered at the origin, this would technically be like x minus h in parentheses squared minus y minus k parentheses squared. So there is a typo. This is supposed to be a 2, that's supposed to be a 2. And same thing here, this is supposed to be a 2, and that's supposed to be a 2. Okay, and now the difference between a hyperbola and an ellipse is the sign. The sign here in the middle is a minus. It still is equal to 1, however. Okay, the sign in the middle is a minus, but it is equal to 1. And it can either go x squared minus the y squareds, or it can go y squareds minus the x squareds. So what that looks like is if I have my axes here for both of these, if it is x squared, kind of opposite of what you think. If your x's are squared, your picture is going to look like this. You're going to have a parabola on the left there and a parabola on the right. And you're going to have your diagonal asymptotes in there as well. If it is y squared minus x squared, it's going to look something like this, where your diagonal asymptotes show you what direction you are going towards. You can't pass the vertical asymptote, or not vertical, but you can't pass the diagonal asymptotes, but you're going to approach them on both sides. So it's kind of the opposite of what you think, because normally x squareds are like your up and downs, right? But if it starts with x squared and it's minusing the y squareds, they're opening to the left and to the right for your hyperbolas. And if it's a y squared minus the x squared, that's going to be your up and down parabolas there, okay? Now, these other formulas and things, like I said, if this is a question on your final, you'll be given this information, so you don't have to have this memorized, but you will need to be able to use that information to answer or graph or do whatever is asking of you on the final. So I'm going to kind of explain it as we go. We're not going to really talk a whole ton about foci, but same thing with the focus of what we talked about on parabolas. A foci is basically like there is a point on the inside of both of those parabolas, and that value is found by doing plus or minus c. And that plus or minus c is found by doing a squared plus b squared is equal to c squared. So using those values down below and solving that equation. But we're not really going to add that in because we just don't have enough time to talk about that fully, okay? But we are going to sketch these two graphs. The first one here, it says we've got x squared over 25 minus y squared over 49. So if I were finding my a value here, instead of it being 25, what's my a value? A would be 5, and my b value would be 7, okay? And if it's an x squared minus a y squared, I know that my parabolas are going to open to the left and the right. Okay, so I'm going to follow the left chart here. It says vertices are plus or minus a, comma 0. So my vertice for my for my parabolas, okay, are going to be plus or minus 5, comma 0. So that means on my graph here, it's centered at 0, 0, but at plus or minus 5, that is going to be the vertex of my parabola. Okay, the asymptotes. Asymptotes.
Wait, sorry, does that say plus or minus? Oh, okay, next.
Following that formula, the asymptotes are going to be y equals plus or minus b over a. So that's going to be plus or minus 7 over 5x. So if I want to graph these, again, it starts at 0, 0 there. And then I've got a slope of up 7, left 5. And then I can go ahead and draw my line. This is my asymptote. And then do the same thing the other way, up 7 over 5. And I can draw my asymptote. Those are supposed to be dashed lines, by the way. Okay, and then if I wanted to finish graphing this, all we got to do is plot my curve approaching both of those asymptotes. Let me fix that maybe if I can. Well, I might just say pretend that it's at this point right there, right, instead. I don't know how to fix it on Explain Everything. Yeah. You guys get the idea. Oh, wait. Is it going to let me?
Okay.
No.
How did you get those?
There we go.
Oh,
Okay. I fixed it.
yeah.
Okay. Thank you. We good now? We agree up 7 over 5?
Yes.
Up 7 over 5? Okay, cool. And then again, your foci is technically a point that is on the inside here of these parabolas somewhere. And those values can be found by following this formula, a squared plus b squared equals c squared. Okay? My domain of this graph, though. My domain, what's the farthest left point that I can be on this graph? Negative infinity, right? And then the farthest right point would be negative 5. And then I start up again at what x value? Positive 5. And I go all the way to infinity. Okay, my domain and range are not going to be the same, right? What's my range going to be? What are all my y values? all of them, right? All the way down to negative infinity and all the way up to positive infinity. All right, last example. We're graphing 25y squared minus 4x squared is equal to 5. If I want to graph this, I do need to get this equal to 1. So what do I need to divide this all by? 9. So dividing everything by 9, we're going to rearrange this here. So this becomes 25y squared over 9 minus 4x squared over 9 is equal to 1. Okay, but however, the formula for a hyperbola or an ellipse is the number in front here has to be what? That number has to be also a 1, right? It just has to be x squared or y squared. So I need to get rid of this 25. So I need to move this 25 down below, and I need to move this 4 down below. And if I want to move it down below, it's going to become a fraction in the denominator. Why did I write 24? So if I rewrite this as 1 divided by 25 times 9, if I would flip this, if I keep change flip, that 25 would come back up on top, right? Kind of weird, but yeah, that's how math works. And then if I did the same thing and I move that 4 down, I'm going to have an x squared on top, and then I'll have 1/4 in the denominator times my 9 value is equal to 1. So now my a squared and b squareds just look a little funny, but I'll have y squared minus x squareds. And then I've got 9/25 and 9/4, or that's just equal to a squared and b squared. That 9/25 and 9/4. So if I wanted to find a, well, what's the square root of 9/25? 3/5. What's the square root of of 9/4? 3/2, right? So my a value and my b value are just fractions in this case, but we are still able to find those two. So now I'm going to follow the right-hand side of that formula sheet there, vertices and equations on y squared minus x squared. So my vertices formula is 0 plus or minus a. So I'm going to have my vertices at 0 comma plus or minus 3/5. And then my asymptotes are the one that's going to be a little funny, because my asymptote formula is a divided by b times x plus or minus. That's equal to y. That's where my asymptotes are going to be. But if I take a and I divide by b, I'm going to have a fraction, right? So I would have plus or minus 3/5 over 3/2. And a fraction and a fraction. If I keep change flip, I'd have 3/5 times 2/3. I don't know why I wrote it like that. 2/3. Those 3's go away. So your asymptotes are actually at y equals plus or minus 2/5 x. And now I can just go ahead and plot these two things, and then I've got my graph. So your vertices, again, it's starting at the origin, is that midpoint there, and then my vertices are going to be up and down a positive 3/5. And my vertical asymptote, I'll try and not mess it up this time, is going up to left 5. Sorry, my diagonal asymptote's there. It's going to look something like that. And then your graph is just going to start on those 2 points, and it's going to approach both sides of your asymptote. And that is your hyperbola.